Hello, Mindsetters. It is another beautiful Saturday, and yes, you are with us. You're tuning into the #1 best learning channel and best learning lesson ever right here on Learn Extra. It is mathematics. We call it an MOS, which means Maths on Saturday. You haven't made any mistake. My name is Abram, and I'm not alone today. I'm with Natasha. How are you, Natasha?
I'm very well, thanks, Abram. How are you?
I'm superb. It's a Saturday, so I don't have any excuses. During the week, you know, you've got a lot of work, but today I'm just all chilled.
Oh, good for you.
Nice one. And what are you having for the Mindsetters?
All right, well, guys, first of all, well done. Congratulations just for getting up so early on a Saturday morning. That's impressive in itself. So today we're going to do paper 2 revision. As you know, it is June exam, so we're preparing Mindsetters for writing their maths paper 2.
I must say this comes in very handy because a lot of Mindsetters have been asking when are we giving them a scope for the exams. So this could be their way of getting a scope.
Absolutely.
Right. Mindsetters, let me tell you what you need to do for today. To join us, one, you need to take your pen and paper next to you and just have your cell phone next to you or your computer and log on to Facebook. Our Facebook link is facebook.com/learnextra. That's where you can ask your questions, or if there's anything that you see that Natasha is going through and you don't understand, stop us and let us know what are your views and your questions, and also get other Mindsetters helping you on the page. And secondly, you can tweet us at LearnExtra. And lastly, download the notes. Already I've posted the link over Facebook. Our link for the notes is learnextra.co.za/live. And also later on in the show, I'll be announcing our winners for Thursday's show for the After Earth competition. So who knows, it might be you. And yesterday, the show, the movie was being launched. I'll tell you more about it because I got a chance to watch the movie. So yes, Natasha, let's get to it before I get carried away.
How was the movie, Abram?
Yo, it was off the hook. It's a must-see. Trust me, I got another view of understanding what could happen after Earth, life after Earth. It's just so amazing. And I really encourage everybody to go see the movie. It's not just only a fiction movie. It is also educational at the same time. You learn a lot. Whether you love science or you don't love science, it is a must-see. Especially for parents also.
All right, guys. Well, there you go from the man himself. So I hope if you went to the movie and you were there on the opening, you enjoyed it. And I hope that you're ready up and early to do maths and, you know, you have your coffees and whatever you need to get you going for the morning. Today we're going to look at some questions from paper 2, and specifically we're going to do the supplementary exam from 2009, and we're going to focus more on the revision that you kind of forget to do, which is the grade 11 work that you really need for grade 12. So, you know, we'll throw in some grade 12 work as well, combine everything together and just remind you of how you should be revising. Obviously at this time of the year, the best revision is do lots and lots of exam papers, which is what we're going to start with you today. All right. So as I said, this comes from paper 2, the supplementary exam in 2009, and we're looking at question 1. All right, they tell you that ABCD is a quadrilateral with vertices, and they give you A, B, C, and D, and they give you the coordinates. You'll see that D has one unknown coordinate, one unknown value. And they say that AD is parallel to BC. As you can see, it is marked on the diagram that those lines are parallel. Okay, so typical exam question. They say calculate the gradient of BC. Hopefully by now you've done this so many times that you don't need the formula sheet to know the formula for gradient. Your gradient is given by y2 minus y1 over x2 minus x1. Okay, so here we're finding the gradient of, and they asked us to find the gradient of BC. So we're going to say gradient BC. So therefore we'll need the x and y values of B and C. We see that B is 3 and 0 and C is 6 and 1. So B, just so that you have it in front of you, is 3 and 0 and C is 6 and 1. Okay, and it's just a straightforward plugging into the formula really. The only little thing that could trick you up here is you must take the coordinates in the right order. So if you're starting with the y coordinates of C, when you say y2 minus y1, you then need to start with the x2 as being 6 and then your x1 being 3. Okay, so that's the only way you could get a little bit tricked up here is if you make a mistake with the brackets. So we're going to say it's going to be 1 minus 0, which is the y coordinates at C, minus the y coordinates at B, all over 6, which is the x coordinates at C, minus 3, which is the x coordinates at B. So this is going to give us 1 over 3. Okay, so that's easy marks, 2 marks there. Gradients of BC is a third. All right, let's have a look at the next one. Determine the equation of AD in the form y equals. So now if you look at AD, we can see that it is obviously a straight line. Therefore, our defining equation, y is equal to mx plus c. Alternatively, you can use y minus y1 is equal to m times x minus x1. All right, guys, whichever one you choose to use there, you'll notice that what you need is the value of m, which is the gradient. Now, you don't have the coordinates of d, you've only got the x coordinate. So where do you get the gradient from? Hopefully you're all up and you're thinking this early in the morning. Remember, they have given you a little bit more information. They've told you that AD is parallel to BC. And what do we know about parallel lines? They have equal gradients. So we know that BC is parallel to AD. So that means that the gradient of BC is going to be equal to the gradient of AD. All right. And we know that the gradient of BC was a third. We've just worked that out. So therefore, the gradient of AD must also be a third. I'm going to use the second formula to work out the equation of the straight line. If you would prefer, you can use the top one. It's just obviously then you'll substitute your x and y values in and work out your y-intercept. But I'm going to use this one, y minus y1 is equal to m times x minus x1, because we've got the coordinates of A as 1 and 6. All right, so we know A is 1 and 6. We know that the gradient of AD is a third. So therefore, I can say y minus y1 will be 6 is equal to the gradient, which is a third, times x minus x1, which is 1. There we go. And we're just going to simplify that, times the a third into the bracket. So we get a third x minus a third. And I'll take the 6 over to the right-hand side, so it becomes plus 6. So I'm going to get a third x. 6 minus 1/3 is going to be 5 2/3. Or you can write that as a third x plus 17 over 3. All right. Okay, so either way, whichever method you use, whichever formula you use, that is the answer you should get for the value for the equation of the line AD. All right. Now, for the next one, part C, they say calculate or show that the coordinates t is actually equal to 8. So if you go to the diagram, you see that they give you the point D and they say it's 7 and t, and you don't know what that t is. Okay? There's several ways you can do this. Okay, you can use the fact that the lines are parallel to each other and use the gradient of BC and use the gradient of AD and help, in that way solve for t. Okay, so you can use the gradient formula. Another way, which is the way I'm going to use, is remember that this point D is on the straight line AD. Okay, so therefore the coordinates must satisfy the equation that we just found, which is y is equal to a third x plus 17 over 3. So since the point D, which has coordinates 7 and t, lies on the line AD, right? Since it lies on the line, we know that if I have y is equal to a third x plus 17 over 3, if I substitute the x value of 7, I should get the y value, which in this case is t. All right, so I'm going to say y is equal to t, and that's equal to a third times x, which is 7, plus 17 over 3. Remember, they've already guided you and they've said to you that show that t is equal to 8. So we're going to see if we get that. 7 times a third is going to give me 7 over 3 plus 17 over 3, which is going to give me 24 over 3, which is in fact 8. So therefore we've shown that t is equal to 8. Okay, and that's an easy, how many marks? Easy 2 marks. So these standard kind of analytical geometry questions, there's absolutely no reason for you to not get these marks. The only way I can see you messing this up is if you're very, very careless. Okay, so try and take it easy with these and be very, very careful, because there's no real tricks in these questions. Okay, it's just a matter of being careless. You might lose 1 or 2 marks. So we've shown that t is equal to 8. Now guys, in an exam, if they say something like show that t is equal to 8 and you haven't been able to do it, just assume the value to help you answer the following questions or the questions that follow. Okay, so if you guys couldn't figure out how to show that t is equal to 8, in your next question d, if it requires using that coordinate of d, just assume that you've shown it and carry on as if t is equal to 8. Okay, because you don't want to lose the rest of the marks because you don't have the value of t. All right, so D says calculate the length of AB. Let's have a look here. So AB, it's the coordinates at A is 1 and 6 and B is 3 and 0. So we're just going to use our distance formula, which once again just requires plugging into the formula. Okay, so this is part D. And we're looking for the length of AB. Right, we know that AB is equal to the square root of x minus x1 squared plus y minus y1 squared. Okay, right. Now remember A was 1 and 3. I just want to go back up and make sure A was 1 and 6. A was 1 and 6, and then B, on your diagram, B was given to you as 3 and 0. So these kind of typical plugging into a formula question, you should get right as long as you don't make any careless mistakes. All right, so we start with x. We're going to say 1 minus 3, and it doesn't matter which order you take it in. So it's 1 minus 3 squared plus y minus y1, so it's going to be 6 minus 0. Okay, so it doesn't matter if you start with the coordinates of A or the coordinates of B, just remember to maintain that order. So if you started with x at A, you need to go to y at A minus y at B. Just make sure you keep the order. So that's going to be 1 minus 3 squared, so it's going to be 2 squared, which is 4. Plus 6 minus 0 is 6. 6 squared is 36. So this is going to be the square root of 40. If you know your laws for surds and that very well, you know that you can rewrite 40 as 4 times 10. And we can then square root the 4 to say it's 2. So we get 2 times the square root of 10. And they could quite easily have asked you to show that the length of AB is 2 root 10, and then everyone gets very confused because I've got root 40. But all you would need to do in that case is just simplify your root a little bit, break it up into a perfect square times the other number, and then you can square root your perfect square. Okay, so they could easily have asked you to just show that AB is equal to 2 root 10. Okay, which is just a matter of simplifying the surd. Okay, so we're almost done with this one. The next part, show that AB is perpendicular to BC. Now, there's an important rule that we learned about perpendicular lines. They're asking us to show that AB is perpendicular to BC, so they want us to show that that angle's 90 degrees. And you learned this rule, I think it was in grade 10 possibly, that for perpendicular lines, the product of the gradients, so the product of the gradients is equal to -1. Okay, so if these lines AB and BC are perpendicular, remember we've worked out that the gradient of BC was a third, right? So if these lines were to be perpendicular, it means that the gradient of AB has to be the negative inverse of a third. So the gradient of BC should be, and this is what we've got to show, it should be minus a third if the lines are perpendicular. Sorry, not BC, the gradient of AB. Okay, so that's our vertical line AB. We want that gradient to be negative 3 because we know that this gradient is a third, and negative 3 times a third is equal to negative 1. Okay, so that's what we want to show, but now we've got to do it. Hey, we can't just assume it, so we've got to use the coordinates of A and B and work out the gradient of AB. All right, I think we're on E, so we're looking at the gradient of AB. Remember, we've got the coordinates of A and B in the one above. So remember your formula, y2 minus y1 over x2 minus x1. So it's going to be 6 minus 0 all over 1 minus 3. All right, so 6 minus 0 is just going to give me 6 all over negative 2, and 6 divided by negative 2 is negative 3. So yeah, we have success, hey? Because we know that the gradient of AB is equal to negative 3. We know that the gradient of BC is equal to a third, and if we were to take those gradients and multiply them together, we will get minus 1, because a third times negative 3 is negative 1. And therefore we know that, and we've learned this a long time ago, since the product of the gradients of the lines is equal to negative 1, that means that the lines are perpendicular. So therefore, BC is perpendicular to AB. All right. Okay, so nice and easy so far. I hope you're all following along. The last one, F, determine theta, the angle of inclination of BC. Now remember, let's look at BC. Your angle of inclination, as they've marked it here on your diagram, so this is theta here, and that's what they're looking for. All right, remember, whenever they're looking for the angle of inclination, when they ask you to find the angle of inclination, it's the angle that the line makes in the direction of the positive x-axis. Okay, so we're looking for this little angle here, theta, which is the angle that BC makes in the direction of the positive x-axis. All right, now you will remember that, and this is part F, in order to find the gradient, in order to find the angle of inclination, we say tan of theta is equal to the gradient. Okay, and by now you already know why that is, but I'll show you again anyway. Remember, tan of theta is equal to y over x by definition, and your gradient is equal to change in y over change in x, and that's where this formula comes from. If I want to find the angle of inclination theta, I simply say the gradient is equal to tan of theta. All right, we know that the gradient of BC is equal to a third. I'm trying to look for the angle theta, so I'm going to say, well, tan of theta is equal to a third. Remember, you're trying to find your angle, so you're going to use your calculator and you're going to go shift tan of a third. All right, let's do that. So we're going to go shift, and it's tan of 1 over 3. And that's going to give me 18,43. Right, so the answer here is 18,43. Okay, and that's the answer for the angle of inclination of this line, BC. And guys, I think you will agree, I mean, that's really, what is that? That's just over 5, That's 15 marks. It's an easy 15 marks to get. If you understand your analytical geometry, it's an easy 15 marks. There's no reason why any of you should not get all of these marks. It's really straightforward application, plugging into your formulae, and I really hope that you're all going to do really well with this section. Abraham, is it time to have a break?
Yes, it is. And talking about having a break, I just want to send this shout out to all the mindsetters that are watching. As promised to you that I'm going to say this shout out to a few of you. So a holla to Silo Arthur, who's enjoying the show and also saying that he got 140 out of 150 on his paper 1 maths.
Well done.
All thanks to Mindset. So well done, buddy, and keep it up. And one last shout out, Tando Gift Gama, all the way from Swaziland. Holla to you too. And thank you to all the mindsetters that are tuning in. But do stay tuned. Don't move anywhere, because after the break, I'll be announcing our winners for Thursday's show for After Earth competition. See you after this. Welcome back, Mindsetters Grade 12s. Now it is your chance now to listen to me and hear who are the winners for our After Earth competition that we've been running. You've seen the trailer and now you've seen the movie just like I did. It was just off the hook. And getting some reviews from also other Mindsetters who've seen the movie, they're just saying it was out of the moon. That's what I got. But otherwise, our winner for Thursday grade 10 show, grade 10 to grade 12, because it was Maths Lit, is Leslie Ann Johnson. Congratulations to you. You got yourself a double ticket for you and your friend to go watch the movie at any time, guys. The reason that it was launched yesterday doesn't mean that it has just ended yesterday. So you can watch it, and you've also got yourself this awesome hamper from After Earth, proudly sponsored by Sony Movies. So hope you're going to enjoy it, and also we'll keep telling you more about After Earth because we learn a lot, and hope you're going to get that chance to share over our Facebook page how was the movie, and if you're still going to see the movie, what are your expectations? But for now, I think Natasha has to continue.
All right, guys, so we're back with paper 2. This is the supplementary exam from from 2009, February, March. And we've just done a question on analytical geometry, basic analytical geometry, showing you really that there's marks up for grab. You know, if you just do lots of past papers and you know your basic applications, it's easy to get 50% at least for maths. We don't want 50, we want more, but it's easy to get that 50%. All right, so some of you were asking for trig, so that's our very next question, and this is from question 5. If you do have the paper in front of you and you're able to follow, if you've got our notes, then you can just go question by question. But if you've got the paper, this is question 5 in the paper, and they say simplify to a single trig ratio and show all calculations. All right, so they give you an entire fraction to simplify. We need to use trig reduction formula, something very important. As you can see, I've drawn up these axes, and this is to remind us about the cost diagram. Okay, there's lots of different ways to remember it. You can just remember it as cost, or all stations to Cape Town, or some other fancy things that I can't say on air. But remember, what it shows you is that all your trig ratios are positive in the first quadrant. In the second quadrant, sine is positive, tan is positive in the third, and cos is positive in the fourth. All right? Also, everything within the first quadrant is less than 90. It's 90 minus theta. If we go into the second quadrant, where sine is positive, we're looking at 180 minus theta. In the third quadrant, 180 plus theta. And in the fourth quadrant, it's all angles that are just 360 minus theta. All right. So we're going to use this diagram to help us reduce the fraction that we have. Okay, and it is important to show your steps here. Tan of 180 plus x. So we say, okay, we first look and see where is 180 plus x. Okay, we know that that's going to be in the third quadrant. We then look at the ratio tan. Is it positive or negative in the third quadrant? And we know that it is positive. So therefore, tan of 180 plus x is simply going to reduce down to tan of x. All right? We do the same thing with the cos. We've got cos 360 minus x. We look first, where is that angle? 360 minus, that's in the fourth quadrant, and we know that cos is positive in that quadrant, so this entire thing is just going to reduce down to cos of x. All right. Now let's tackle the denominator. We've got sine 180 minus x. We look at the angle 180 minus x in the second quadrant. Sine is positive there, so that's just going to become sine of x, right? Then we've got times cos 90 plus x. Now this one's slightly different. We haven't dealt with 90 plus x on our diagram. Now, remember, everything in the first quadrant is 90 minus theta, or 90 minus x, or whatever your angle is. When we want to go into the next quadrant, the quadrant next door, another way we can say it, instead of 180 minus, is we can say it's 90 plus x. Okay, so 90 plus x is the same as 180 minus theta in the second quadrant. So it will take you to the same place. However, because you're dealing with 90, you need to remember your co-ratios. All right, so this is, now you've done this in grade 11 already. Your co-ratios, remember cos of 90 minus x is sine of x. All right, and then let's include this one, cos of 90 plus x. And what you do here is you first look at 90 plus x and you look at the cos. We know that that's 90 plus x is in the second quadrant. Now remember, cos in the second quadrant is negative. So we first sort out the sign. Then we use the fact that our co-ratio, cos of 90, is going to change to sine. So cos of 90 plus x is going to give me negative sine of x. So as soon as you see the 90, you've got to think co-ratios, I need to change from cos to sine, or from sine to cos. But the negative and the positive determines whether your ratio is negative or positive. So cos of 90 plus x would be negative sine x. Cos of 90 minus x is just sine x. If we were to take it one further and go sine 90 plus x, remember 90 plus x is in the second quadrant and sine is already positive there. So using our co-ratio, sine of 90 plus x is just going to become cos of x. All right, but hopefully you guys don't have too many questions about this now because you did do it in detail last year. So cos of 90 plus x is just going to be negative sine x. All right. Then we've got plus cos 540 plus x. Now this one requires a little bit of simplification, and I'm going to do it on the side, but you can obviously show this within your sum, but I just need a little bit of space to work with. So I've got cos 540 plus x. This is not something you're used to because all of your angles 180, 90, 360. This is 540. So what you need to do is you need to subtract 360 from the 540 to reduce that 540 to something that you're used to working with. All right? So if I say 540 minus 360, that's a revolution. It takes me back to wherever that is. It takes me back to the same spot. All right? So I say 540 minus 360, and if you need to do it on your calculator, then please do. It's 540 minus 360. And we get 180. 180 is something that we're used to working with. So I can rewrite this 540 as 180 plus x. Now I've got it into a form that I'm comfortable with. All right. So when you get angles that are bigger than 360, simply subtract 360 to get it down to something you're familiar with working with. All right. So 180 plus x, we know 180 plus is in the third quadrant and cos is negative there, so this is going to become negative cos x. All right, and then the last bit of this fraction in the denominator, we had times cos negative x. Now remember, for your negative angles, you're actually going round the axis in the other direction. All right, so cos of negative x, it means you started at north, you went around like that. It's going to take you into the fourth quadrant. So that's just going to become positive cos x, because cos is obviously positive in the fourth quadrant. All right, we're ready to simplify. You need to remember your trig identity. Tan is the same as sine x over cos x. So we can simplify to that. Times we've got cos x over 1. All right, and the bottom, sine x times negative sine x is going to be negative sine squared x. And cos x times negative cos x will be negative cos squared x. All right, we can see that the cos x and the cos x are going to cancel there in the numerator, so you're simply left with sine x in the numerator over, now there's a little trick here because I can rewrite this negative sine squared x, negative cos squared x into something I'm familiar with if I take a negative out. So I divide through by the negative, I'll be left with sine squared x plus cos squared x. Okay, and that's an identity you all should be very, very familiar with now. Sine squared plus cos squared x is equal to 1. So I'm going to get sine x divided by negative 1, which is negative sine x. All right, and that is 8 marks. Okay, again, if you know your trig reduction, you know how to use the cast diagram, really, and you know your cofunctions, no reason to lose any marks on this question. And I hope for those who said, okay, I don't really understand trig and that, I hope that this is making it a little bit clearer for you so that you can be successful at this section in your maths paper 2 exam. So that's 8 marks. I'm going to quickly see if any of you have any questions before I move on to the next one. Abraham?
For now, it's just the mindset is saying they need more work on series.
Series is paper 1, so that's not going to happen.
Sorry for that, Vincento. And another one has a problem with 3-dimension on trig.
All right, guys. So if you're struggling with paper 1, I don't think you in grade 12 if you're thinking about it now because you already wrote paper 1, and today we're just doing paper 2 revision. Maybe some of your school timetables are a little bit different, and maybe you are writing paper 1 in the following weeks. Then remember to just go online, check all the previous notes and shows that we have done. 3D trig, we will be getting to that later on in the show. Okay, carrying on with trig though. Again, remember this is from the supplementary exam 2009. This is now question 5. And again, we're simplifying this trigonometry fraction into a single trig ratio. All right. So now this is more grade 12 because we see we've got double angles. All right. So you need to remember your double angle formulae. Obviously, they will be given to you on a formula sheet. Okay. Remember with cos 2x, you've got a few options, right? We can change it to either 2 cos squared x minus 1. That's the one option. Or we can change it to 1 minus 2 sine squared x. Or you can change it to cos squared x minus sine squared x. Okay, but remember all of these are given to you on your formula sheet, so you don't really need to worry about remembering them. Okay, but you need to know when to use it, and it really just depends on the question. In this one, because I can see there's already a sine x in the numerator, I'm going to go for the second expression, which already has a sine x in it. So I'm going to change cos 2x to 1 minus 2 sine squared x. All right, and then we've got a minus sine x. In the denominator, sine 2x is really nice because the only expansion is 2 sine x times cos x. Okay, and then it's minus cos x. We'll just bring that down. Okay, let's simplify in the numerator, times the negative into the bracket. So I get 1 minus 1 is just going to give me 0. Negative times the negative is going to give me a positive. So I'm going to get positive 2 sine squared x minus sine x all over. At the bottom, we can take out a common factor of cos x, but I'm not going to do it just yet. I'm going to keep that factorizing for the very next step. So we've got 2 sine x cos x minus cos x. Okay, now when you get to this step, there's really not much more you can do in terms of expanding. Okay, everything is as expanded as it can be. So what we can do now to simplify this is we can see that in the numerator, we've got a common factor of sine x. So we can take sine x out as a common factor in the numerator. When we do that, we'll be left with 2 sine x. Remember, when you're taking out a common factor, you're dividing each term by what you've taken out. So if I say 2 sine squared x divided by sine x, sine squared divided by sine is just going to give me sine x. And then sine x divided by the common factor sine x is just going to give me 1. In the denominator, we see that we have a common factor of cos x, so we can take that out. And we'll be left with 2 sine x minus 1, which works out quite nicely now because we can simply cancel those common brackets out. And we get something which we can simplify. We've got sine x over cos x, and if you know your identities, you know that sine x over cos x is tan x, so that works out really nicely. We get down to just one trigonometric ratio for this entire big fraction that we were given in the beginning. Okay, and the only thing here I think really that could have tripped you up is you had to realize, okay, well, what am I going to use for cos 2x? How do I expand it? If you chose something different, because I chose 1 minus what did I choose? I choose 1 minus 2 sine squared x for cos 2x, and it worked out nicely and simply. If you use any of the others, you still get to the answer, but eventually in many, many more steps. So all of them will eventually get you to the same answer, but a lot of them, a lot of the times, if you choose the wrong one to work with, you'll end up with a whole big mess, and then you'll realize, okay, maybe I should have used something else. Okay, so it all really just depends on the question which expansion of cos 2x you should use. All right, so we've done 2 trigonometric questions, and I think it's time for a break.
Yes, indeed. But I have to tell you, mindsetters, that you can join us from the 20th up until the 22nd of June for the Career Indaba happening at the Sandton Convention Center. So make sure that you register. Details are also on our Facebook page. It's for free. So come learn more about your different careers and help yourself choose the right career. It's all about you. So make sure that you do register for free. See you after the break. Welcome back, matriculants. Now it is still our MOS, which means Maths on Saturday, or Me on Saturday, or Mindset on Saturday. Depends on how you want to roll it. But otherwise, now I need to tell you about our Curio. You can take your cell phones and go to Mixit. We have the instructions right on our Facebook page. Your code is simply M12. M12. You can help us and help the teachers also assess you, answer those questions, and let's see how do you understand today's lesson. And if it's helping you, also share on Facebook and let us know how is it helping you. Because I've seen that already. There's a comment that says, wow, Natasha, I so hate paper 2, but Natasha has just made it so simple, worth waking up and watch the show. So thank you very much, Mindsetters, for all those comments. Keep learning, and let's help one another on the page too. Natasha, let's continue.
All right, great, guys. So I've had a look at some of your comments, and some of you seem to be a little bit stuck with this cos 540 plus x. So I just quickly want to discuss this before we move on. All right, I explained it very quickly because I think you guys would have done this by now in grade 11, but some of you are still a bit lost. So cos of 540 plus, remember, we get to a point where we end up with a revolution situation, and we get exactly the same point by adding or subtracting 360. So what you can think of it as is 540 is 360 plus 180, right? Okay, so I can rewrite 540 as 360 plus 180. Okay, and then obviously we've got the plus x there. But even simpler is I can group this up, so it becomes cos 360 plus 180 plus x. Okay, so I've done nothing fancy there. I've just put the 180 plus x together in its own little bracket. Now remember, 360 plus is a revolution. It does nothing. It changes nothing with this entire expression inside the bracket. So cos of 360 plus 180 plus x is simply going to become cos of 180 plus x. Okay, because remember, 360 plus, you're going to end up, so let me show you again on the diagram. So we've got 360 plus. Remember, this is 360 minus. So 360 plus means I'm going around again. So this is 360 plus theta. It takes you into the first quadrant. Everything in the first quadrant, remember, is positive. So cos of 360 plus will change no ratio. So cos will still remain cos, positive, and 180 plus x is now what you've reduced it to. And then you can say, well, cos 180 plus x, that's in the third quadrant. So this is going to be negative cos x. Okay, and I hope that's cleared it up for all of you who were having problems with that specific section. But for now, we're just going to move on to our next question. All right, and this is question 3. Again, remember, we're working from 2009 supplementary exam. We're doing a little bit of trig in this session. And this is question 6.2. Okay, so we are asked, or we are told, that it is known that 13 sine alpha minus 5 is equal to 0. Tan of beta is negative 3 over 4. They give you restrictions. They say alpha is an element from 90 to 270, and beta is an element from 90 to 270, and then they say determine. Now what I like to do with this kind of question, before I even look at what they want, let's make some drawings, because whenever they give you this kind of question where they've got they identify your quadrants and they give you ratios, or you can work out ratios, trig ratios, right? You're generally going to use those triangles. Remember those 90-degree hypotenuse, right angle triangles that you've got to put into the right quadrant? That's what we've got to do. Okay, so first thing we're going to do is I'm going to take 13 sine alpha minus 5 is equal to 0, and I'm going to simplify that to get sine of alpha is equal to, take the 5 to the right hand side, divide by 13, and we get sine alpha is 5 over 13. Then they've told you that alpha is an element from 90 to 270. So you need to identify, oopsie, that looks, there we go. You need to identify where alpha is going to be. So if you have an axis, right, we know that alpha between 90 and 270, it means greater than 90, less than 270. It restricts you to these two quadrants, the second and the third. All right? We also know we're looking for a ratio where sine of alpha is positive, because you can see 5 over 13 is positive. So therefore, we know sine is positive in the second quadrant. So those two ticks tells me that my right angle triangle has to be in the second quadrant. Remember, when you draw this, you extend from the origin, you extend a line out, and then you drop it perpendicular onto the x-axis. The angle that you're looking at is this one, which is alpha. All right? And we are given that the ratio is 5 over 13. Remember, sine is also opposite over hypotenuse, or y over r. So from my angle alpha, I look and I see, okay, I know that sine is y over r, and I know that sine is 5 over 13. So if you're using opposite over hypotenuse, this is your angle here. You're looking at opposite being 5, hypotenuse being 13. Okay, generally for these kind of questions, you need to solve that triangle, which means you've got y, you've got r, you now need to find x. Okay, to do that, we use Pythagoras. So we've got x squared plus y squared is equal to r squared. We know y, we know r, we need x, so therefore x squared is going to be r squared, which is 13 squared, minus y squared, which is 5 squared. So that's going to give you 169 minus 25, which is 144. So if x squared is equal to 144, remember the square root is going to be plus or minus. The square root of 144 is 12. Okay, remember when you take the square root, it's always plus or minus. Now, if you look at your diagram, you need to decide whether x should be positive or negative. Because we're on the left-hand side of the y-axis, remember your x values on the left are negative. Therefore, x is not going to be positive 12, it's going to be negative 12. So therefore, the x value here is negative 12. Okay, so we've completely solved that right angle triangle. Okay, and what I'm going to do is, before I even look at the question, I want to do the second bit. Okay, so this is where we've sorted out the alpha diagram. Now look at the beta diagram. So we're going to draw another axis, and we'll use green for showing that we're working with two different triangles. And let's use a white. Okay, very colorful this morning. Hopefully you're all awake with all the colors. All right, we've got tan of beta is negative 3 over 4. We also told that beta is between 90 and 270. So again, we know 90 to 270 is second and third quadrant. But they tell you that tan is negative 3 over 4. Now remember, tan is not negative in the third quadrant. It's only negative in the second quadrant. So once again, our diagram for beta is going to go in the second quadrant. Okay, so working from our angle beta, we know that tan is opposite over adjacent, or y over x. So it's going to be 3 over 4. The x value is negative because obviously we're on the right-hand side, the left-hand side of the y-axis. All right, so x is negative 4, y is 3. I need to work out the radius. So once again, I use Pythagoras. And I say x squared plus y squared is equal to r squared. In this case, we are looking for r. So we're going to get negative 4 squared plus 3 squared is equal to r squared. So we're going to get 16 plus 9 is r squared. So that means r squared is 25. And r is just going to be positive 5. Now remember, with your radius, because it is an actual length that you're drawing, it's not an x coordinate, it's not a y coordinate, it's a length. Length cannot be negative. So when you're looking for r, your radius, remember it's the radius of a circle. So it needs to be positive. So therefore, when you're taking the square root, it's not plus or minus 5, it's just plus 5. Okay, so we're never going to have the negative option when we're looking for the radius in these Pythagoras questions. So the radius here is just going to be positive 5. Okay, so I wanted to draw these two diagrams just so that we have them there. So when we need to answer the question now, we can simply look at the information we already have. So the first one asks you to find cos of alpha. So if they're talking about alpha, they mean that we need to use our first diagram. Okay, so we go back up to the diagram, and then it's just simply because we've got the diagram, it's just simply reading off. We know that cos is adjacent over hypotenuse, so it's going to be negative 12 over 13. All right, and that's easy done. So cos of alpha is negative 12 over 13. Remember, just by the way, you need to show these diagrams to get all the marks for this question. You have to show the diagrams. So don't just make a tiny little thing for your own, use on the side. You need to include it in your question so that you get all the marks for the question. We have to see these two diagrams. All right. Okay, the next one says find cos alpha plus beta. So this is now grade 12 work because we need to remember the expansion for our compound angles. Well, it will be given to you, but it's good if you know it already. Just means that you've been doing a lot of revision. So cos alpha plus beta is going to become cos alpha. This is just the expansion times cos beta minus. Remember, you always change your sign with the cos one. So it's become sine alpha times sine beta. All right. Cos alpha, we've already worked it out. It's just going to be straight from our diagram, minus 12 over 13. Now for cos beta, you see if we hadn't drawn that diagram already, we'd have to now at this point go and draw it. But because we've got it already, we can simply read off. Cos of beta is going to be negative 4 over 5, adjacent over hypotenuse. And then it's minus. Sine of alpha, we were given, remember they actually told you in the beginning what sine of alpha was. It was 5 over 13. And then for sine of beta, we go to the second diagram and we simply read off. So it's going to be opposite over hypotenuse, which is 3 over 5. Okay, at this point, you can get out your calculators and do it that way if you like. But we can simplify this. I mean, we've got the same denominators. It should be simple enough. Minus times a minus is going to give me plus. 12 times 4 is 48. 13 times 5 is 65. Minus 5 times 3 is 15. 13 times 5 is 65. And then 48 minus 15 is going to give me 8 minus 5 is 3. 4 minus 33 over 65. Okay.
Right, there's a question, Natasha.
Yes.
Right, on that same question. Ketini Shingani says, I'm lost. Why did you say minus 12 divided by 13?
For cos?
Yes.
All right, okay, she would have to have been following right from the beginning, because remember what we showed you is that they gave you 13 times sine alpha minus 5 is equal to 0, so we rewrote that as sine alpha is 5 over 13, and then we had to draw this Pythagoras triangle in the right quadrant. Remember they told you alpha was between 90 and 270, so we know that that means that sine had to be in the second quadrant, and I've already shown you why. And we know that sine is opposite over hypotenuse, so we filled in the opposite, or the y value, is 5, the hypotenuse or the radius is 13, and we simply used, as I showed you before, we used Pythagoras to get x squared plus y squared is r squared. We used Pythagoras to get that x was negative 12. Once we've got the x value, it's simple to just read off there, because then cos alpha is just going to be adjacent over hypotenuse, which is negative 12 over 13. Or if you prefer, if you use x's and r's, cos of alpha is x over r, still the same value, so it's still negative 12 over 13. So I think the only reason you would get confused there is if you just watch the show now and you didn't really follow it, because I went over it in quite a lot of detail. Now, these kind of questions are very, very common in the exam. And as I said before, the best thing for you to be doing now is lots and lots of exam revision. Go through lots and lots of past papers so that you start coming across similar questions. And, you know, just by seeing the same thing over and over again, you know what to practice and you know where you still need a bit of work. All right. Is there anything else, Abraham?
I think we can take a short break and then we'll continue right after it.
Absolutely.
Right. Mindsetters, do stay tuned, and remember you can also go to Mixit and do our Curio assessment and let us know how do you find the lesson. Is it helpful, and where are you still struggling? That's where we'll see. Your code for today's show is M12. So go over Mixit and check out Curio and assess yourself and help us to assess you too. See you after the break. Welcome back, matriculants. Now, I have something so special that I need to tell you. June 16 is, there's two things happening during that day. One, it is Father's Day, and secondly, it is Youth Day. Now, we are giving you an opportunity to send your dad a special message. So go to our Facebook page. I'll share the link also for the Father's Day special message, and let us know what are your wishes for your dad on June the 16th. And also, if you can't go over our Facebook page, I'll also post a link to our website. That's where you can also get a form with a message. Who knows, it could be you, June 16, whereby you'll be seeing your message on the screen live that day, and you can tell your dad that, see your name there and see the message that I have for you. If you don't have any present, this could be your awesome present to your dad, and also celebrating Youth Day. Natasha, let's continue.
Okay, guys, so we've done quite a lot of math so far, analytical geometry, a little bit of trig. I hope that you're all understanding and you're all following. And if you have any questions, please let us know. Okay, so we're going to continue for a little bit with trig. And remember, this is coming from the supplementary exam 2009. And this is question 6.3. Okay, we are asked to solve for x. And they say that x is an element from 0 to 360. So they give you the entire domain for that. And you've got to find the values for x on that domain. If a half times cos x is equal to 0,435. Now you can see it's only for 3 marks. So you could just simply do the way you would do this in grade 11, or you could use general solution. I'm going to use general solution, but if you want to do it the other way, please feel free, where you work out your quadrants and you say, okay, cos is positive in the first quadrant and the fourth quadrant, you can do it that way. But as I say, I'm going to do general solution just because you will also get general solution questions. Okay. First thing we need to do is we need to isolate the cos x, which means get rid of the half. So we divide both sides by a half. So 0,435, we're going to divide that by a half, which is the same as multiplying by 2. Okay, so it's 0.435 times 2. And that gives us 87 over 100, or 0,87. So we've got cos of x is equal to 0,87. So it's just a single ratio. Very easy to solve this from here. You can just use your calculator and work it out. As I said, I'm going to do the general solution method. So I'm going to say x is equal to, now remember, whenever you're dealing with cos in general solutions, it's always plus or minus your reference angle plus k times 360. Okay, and remember, you'll always put in there k as an element of integer values. All right, so in order to work out the value for our reference angle, we say on our calculator, shift cos 0.87, and that gives us 29,54. So x is plus or minus 29,54 plus k times 360. Now remember, you are restricted to between 0 and 360. Okay, so on your axis, that's the entire, all 4 quadrants. If you were looking at graphs, then it's a different story. But on your axes, we're looking from 0 to 360. We're looking for where cos is positive. So it's obviously in the first quadrant and the second quadrant that you'll get answers if you're using the method of my reference angle and then 360 minus that angle. So that's a different method. Okay. What I'm doing is I'm saying I've got my general solution, x is plus or minus 29,54. I'm going to substitute values for k that will keep me within this domain, so within 0 and 360. All right. So for example, if I substitute k is 0 when x is 29,54, so I'm just going to show you here, when k is 0, so if k is 0, and we're looking at x as being 29,54, I'm going to get 29,54 plus 0 times 360, and obviously 0 times 360 is just going to be 0, so your answer is just going to be 29,54. The other option we can take, and you can go through them, but the only other one that's going to work is when k is 1 and x is negative 29,54. So if k is equal to 1 and we're looking at x being negative 29,54 plus 1 in place of k times 360. So I'm going to get 360 minus 29,54. Okay, so it's 360 minus that answer, and we get 330,46. Okay, or x is equal to 330,46. So therefore our solutions for x are either 29,54 or 330,46. Obviously, it's a very short sum. You don't have to show as much working as I did. I just showed it to you so that you understand a little bit better. Okay. All right. Now, I saw on the page that some of you were also asking for work on transformations, which is what we're going to do now. Remember, they do give you the formulae to use for transformations when you're doing the grade 12 transformation. So that will be given to you on the formula sheet to find the x and the y values. Okay, let's read this one. They say, show that the coordinates of p prime, the image of p, so there's p there, and they're saying show that the coordinates of p prime, which is the image there, is rotated about the origin through an angle of 135 degrees, and importantly they say in the anti-clockwise direction. So anti-clockwise, it means, as you can see in the diagram, it's going that way. All right. So that's 135 degrees. That will take you from the point P to the image P prime. Okay. Now remember that formula that you've got on your sheet, it's given to find the coordinates in the anti-clockwise direction. If the rotation was instead in the clockwise direction, then you'll have to change your theta to negative theta. Okay, you know what I'm talking about. You've got the formula sheet, and hopefully you've done enough revision on this section already. But if you haven't, you will get there. But if you have that formula, you know exactly what I'm talking about. The formula is given to you in the anti-clockwise direction, and if the question says in the clockwise direction, you need to change theta from positive theta to negative theta. Okay, all right. So the question says we need to show that the coordinates of p prime, and they give you the coordinates, and that's what you've got to show that it's equal to. Okay, all right, so let's get started with that. Okay, so here we're looking for p prime, and we're looking for the coordinates x prime and y prime. Now, as I was saying, you do have that formula in your formula sheet. So x prime, which is the image, is given by the x coordinates at A times cos theta minus the y coordinates at A times sine theta. And then you get the y coordinate by saying the y coordinate at A times cos theta plus the x coordinates at A times sine theta. Okay, so this is the formula I was talking to you. Well, it's not really a formula, but it's an expression to work out your coordinates of your image point. Okay, so you will be given this on your formula sheet. So we need to work out the x coordinates at p prime. So we're simply going to say x a cos theta, y a sine theta. And all we are given at the point P, we don't have actual values. Do you see? We've just got x and we've got y. So therefore, this entire expression is going to be in terms of x and y. Theta is obviously 135 degrees. All right, so let's do it. So to find x, we're going to say the x coordinate at A, which is just x, times cos of theta, and theta was 135, minus the y coordinates at A, which is just y, times sine of 135. Okay, just simplify that. So this is going to be x. Cos of 135, you can show the reduction on your calculators. You can do the reduction, or we can use our reduction method, where we can convert 135 to 180 minus 45. Okay, minus y times sine 180 minus 45. Okay, and we know that cos in the second quadrant is negative, so this is going to become negative cos of 45 minus y, sine of 180 minus 45 is just going to be positive sine 45. All right, so this is going to be negative x cos 45, negative y sine 45. At this point, you can just plug in cos 45 and sin 45 into your calculator. Sadly enough, I've done so many of these, I know the ratio in my head. So cos of 45 is going to be root 2 over 2, but you can use your calculator to confirm, minus y times root 2 over 2. And you can simplify that to negative root 2 over 2x minus root 2y over 2. Okay, so let's have a look and see if our x coordinate is correct. Okay, because remember they told you what it needs to be. Negative root 2 over 2x, negative root 2 over 2y. Yay. So we've got the x value sorted out. Let's have a look at the y value. All right. So here, remember, we're using this formula now, where y is equal to the y coordinates at a times cos theta. So it's going to be y cos of 135 plus the x coordinates at a times sine theta. So it's just going to be x sine 135. All right. So we've already reduced it. I'm not going to do it again. This is going to become negative cos 45 from the reduction we've just done, plus x sine 45. All right, so this is going to give me negative y cos of 45 is root 2 over 2 plus x root 2 over 2. You can just rewrite it if you prefer, so it would be negative root 2 over 2y plus root 2 over 2x. Okay, and then we're just going to compare it to what they wanted us to show. Negative root 2 over 2y plus root 2 over 2x. So we've got the y coordinate correct as well. Okay. This is just really a straightforward application of using the method to find your coordinates if you're given the angle of rotation. Really straightforward, 4 marks. Okay, let's look at this second part. They say M now, M prime is the image of M24 under a rotation about the origin through 135 degrees. So it's sounding familiar. In the anti-clockwise direction, determine the coordinates of M using the results in question A. If they say using, please don't go ahead and start the whole thing from scratch again. You're going to just waste time. You're going to spend too much of time on this one question that's worth 2 marks. Okay, so if they say using, you need to use what you've just shown. All right, so basically it's exactly the same rotation. They've just now given you the coordinates of M, and they want you to find the coordinates of M prime. So it's exactly the same thing that we've just done. And we've just shown how we would find the x and y values of the image. All right. So all we've got to now do is substitute the values we've got for M, which is 2 and 4. All right. So remember, we've shown already from the previous question that the coordinates of M prime, the image was going to be minus root 2 over 2y plus root 2 over 2x. And then here we had negative root 2 over 2. Okay, remember I'm getting these from what we've just worked out. So here's the other one, negative root 2 over 2x minus root 2 over 2y. Okay, so this we've got just from the previous question. We've already worked that out. Now, the only difference is we know what x is, we know what y is. Okay, remember they told you that M was the point 2 and 4. So all you really need to do is to plug in those values for x and y and just simplify this expression. All right. So we're going to get minus root 2 over 2 times x. Remember, x was 2. In fact, what I'm going to do is I'm going to do it separately because it is quite long, these expressions And you might get a little bit confused with the x's and y's. Okay, so here we're working out the x value, right? So it's going to be minus root 2 over 2 times x, which is 2, minus root 2 over 2 times y, which is 4. Remember, the 2 and 4, where did I get it from? They gave it to you. Okay, x is 2, y is 4. Simplify this. So we get the 2's cancelling. 4 divided by 2 is just 2. So I get minus root 2 minus 2 root 2, which is negative 3 root 2. Okay, so that's the x coordinate of that point. All right, then we're going to do the same thing to find the y value. Okay, so it's going to be negative root 2 over 2 times 4 plus root 2 over 2 times 2. So I'm going to get negative 2 root 2 plus root 2, which gives me negative root 2. Okay, so therefore the coordinates of m prime, simply the ones we've got there, negative 3 root 2 and negative root 2. So that's the coordinates of m prime. All right. Okay, so are we ready to carry on? Are there any questions, Abram?
Yes, there are some questions, but I think we should just take a net break and then we'll treat them after the break. Right, mindsetters, do not go anywhere because after the break we'll be taking some of your questions. And if you still have a lot of questions, go to facebook.com/learnextra. See you after this. Welcome back, mindsetters. As learning is in progress, I just want to take this quick shout out to Mapula Mithape, all the way from Limpopo in Mountain View High. Holla at you because you said I should please holla at you. And to all the mindsetters watching, holla back at you. Natasha, let's continue.
All right, guys. So we've done so much today. This is probably going to be our last question for this show. So let's get into it straight away. Okay. So they say determine the minimum and maximum values of the following, and they give you an expression for f of x. They say f of x is equal to 1 over 3 sine squared x plus 4 cos squared x. Now what I want to do is I want to rewrite this expression, okay, because it makes no sense really as it is currently. I'm going to rewrite 4 cos squared x as 3 cos squared x plus cos squared. So obviously that's going to give you 4. Okay, then from the beginning you can rewrite that as 3 into sine squared x plus cos squared x, which we know is 1. So your expression simplifies to 1 over 3 plus cos squared x. So in order to answer this question, you simply need to know the maximum and minimum values of cos squared x in order to get the minimum and maximum values of 1 over 3 plus cos squared x. So we know that, remember from your cos graph, we know that the maximum value that the cos graph goes to is 1. So therefore, remember, if this fraction is big, then the entire, if the denominator is big, the entire expression is smaller. Okay, remember, as your denominator gets bigger, your fraction gets smaller. All right, so therefore, 1 over 4, when the cos graph is at its maximum, will be the minimum value of this function. And then the maximum value, because you're looking at the cos squared graph, and if I've got time, I'm quickly going to show you, the minimum value of the cos graph is going to be 0 because we're squaring it. So therefore, your maximum value will be 1/3. And I'm quickly going to show you, I've just drawn the cos graph. This is your normal cos graph. When you square it, you're going to get a graph that looks like this. This entire negative portion is going to reflect upwards. Okay, so you don't really ever have to draw this, but you can see from the diagram that the minimum points of this cos graph will then be 0. So when the cos graph is at its minimum, then that entire expression, 1 over 3 plus cos squared x, will be at its maximum. So therefore, the maximum value will be 1/3, and then the minimum value is 1/4. All right, so I hope that you all enjoyed today's session and you've learned a whole lot. And I hope that we've managed to answer many of the questions and many of the problems you had from this paper. Cheers and good luck.
Thank you so much, Natasha, and thank you to you, Mindsetter, for watching this show. See you some other time.